Good afternoon, everybody. Thanks for coming. It's a real honor to present here at Black Hat. My name is Jason Nichols. I work for a company called SEIC, and one of my many roles with the company is to try to translate to our customers how complicated technology solutions are of value to them. In addition, I'm also a gamer. In my personal life, I spend way too much time playing computer games. And some of you may have the same challenge yourselves. Just to get a sense of the room, how many gamers in the room? That's a lot. And it kind of confirms a hypothesis of mine, which is the cybersecurity community shares many similarities with the gaming community. And if you attended the keynote session yesterday morning, I was really struck by the comments from the gentleman from Facebook on the strength of community and how people within the communities can work with each other. And you'll see through my talk how gaming and cybersecurity can complement one another. I never thought that I would join the two together, but you'll see why. I've timed my talk to be about 40 minutes, so there should be time for questions at the end. So I would certainly welcome questions at the end of the talk. All right. Here we go. All right, so just to give you a little bit of background on the genesis here for this talk. To me, cybersecurity is a fantastically interesting subject. And some recent examples of what's happened over the last year kind of illustrate that. For example, the release of the Mirai open source kit that allows any of us to launch distributed denial of service attacks against internet sites and the devastating effect that that can have on backbone internet infrastructure. It's kind of a new thing. In addition, what recently happened in Eastern Europe, the picture shown here is of a grocery store infected with malware from the NotPetya attack, and it's just interesting to see the impact that cyber attacks are starting to have on basic consumers. And these are just two really interesting examples that I see that illustrate the pace at which cybersecurity is advancing and the complexities that those of us are involved with it have to deal with on a day-to-day basis. So what I want to describe to you is a couple of issues that I see in the cybersecurity industry, particularly those faced by the people that we support, our customers, our partners, our fellow employees. And the first issue is that cybersecurity has always been challenging from a technical perspective, but it's getting a lot harder, in my opinion, based on what's evolving in our industry. And I thought this tweet that I saw recently on a Gartner presentation and then responded to by the gentleman, the Gruck, I don't know if I'm pronouncing his handle properly. But if you look at this tweet, I'll read it to you because it may be hard to see. This quantum secured blockchain can protect IoT devices from cyber attacks using a virtual cloud infrastructure. And the response is, bingo, I win. That's a lot of technology that's being described in that very short sentence. I think most of the people in this room can probably decompose that statement and understand the value within, but put yourself in the shoes of our customers and our fellow colleagues that do not possess the same skill sets. How on earth are they going to start understanding the importance of what's being explained here? To me, that's a problem, and it's getting worse. And so cybersecurity is going to continue getting more complicated and more challenging, in my opinion, due to just a few things that I list here. One is the Internet of Things is going to rapidly diversify attack vectors and targets. This notion of virtualization and abstraction of computing systems and networks through our customers' migration to the cloud, that's going to make it a lot easier for our customers to deploy rapidly a vast number of assets. And the blurred lines between threat actors, this is of special interest to me in that in the old days, so to speak, it was pretty easy to figure out who the attacker was and who the target was. Increasingly, it's getting a lot harder. Issue number 2, skill deficit. So I lifted this quote from a combination of Forbes magazine, who themselves were quoting Cisco, and it's an interesting quote. This is from 2016. And basically it states that there are 1 million cybersecurity job openings, and this is last year. So my first comment to all of you is congratulations, you have very good job security. But it's kind of scary if you think about it. If they're right, and that demand is going to rise to 6 million open positions in 3 years, what effect is that going to have when you have that many open positions? That means cybersecurity positions are going unfilled. That means there's going to be a very significant deficit in cybersecurity skills. Obviously, those of us in this room and our colleagues are going to help address that deficit, but mistakes will be made because of that problem. And so we need to figure out how to address that. Issue number 3. So if you think about all of our colleagues and our customers that are not filling information technology or cybersecurity positions, think executive management, finance, staffing, procurement, contracting. These are just a couple of examples of people that make decisions every day that affect security for an organization. Do you think that those people have a good appreciation for cybersecurity attack and defense? I think they know about it, they understand the terminology, they understand risk, but they don't really understand how an attacker thinks. They don't really understand the pressure that defenders have when they're under constant attack from many directions. They really don't get it, and therefore their decision-making process is going to be flawed as a result. Whaling, for example, is a new term that I just discovered a couple weeks ago. That's where a CEO or a chief financial officer, for example, is targeted with a very precise spear phishing campaign, and people have been fired for cutting checks to a threat actor. And on and on here. I think in terms of things like procurement, that's a really big deal when you're thinking about supply chain security. How secure are the products and services that our organizations are procuring? There's a lot of people that are making decisions about procurement language, contracting, staffing, recruitment. These all have fundamental effect on security, and these people need some help. Issue number 4, tech staff. So primarily what I mean by this is information technology staff, perhaps our colleagues that are not necessarily filling cybersecurity positions, but people that are very familiar with information technology, software development, that sort of thing. The picture that I embedded here was really interesting to me. At one point in my career, I was involved in product management, and never did I ever imagine that there would be military staff with assault rifles in my office requesting access to source code. But this happened recently at a company called MEDOC. And the issue there was that there was a suspicion that malware was inserted inside the supply chain of software, and that malware was delivered through a trusted channel. So that's a valuable lesson to everybody who's involved in product design, software development, maintenance. How do we address that? Do you think that if people in those positions knew more about cybersecurity, this problem could get a little bit better? I think so. So issue number 5, specialization within cyber. So I'm talking to all of you in the room. I don't know if you're familiar with the NIST NICE taxonomy. This is a very useful taxonomy that defines cybersecurity, knowledge, skills, and abilities. And this is the top level view of it. And there are flaws in this taxonomy, but it's very useful for reference. And a question that I would pose to all of you is, what box are you in? Are you a specialist within one of those boxes, or are you more of a generalist like myself? And my point is, if you specialize within one of these areas, then you probably have some blind spots in some of those other areas. And if you're asked to support a use case in one of those other areas, then you may have an issue. Conversely, if you're like me and you know a little bit about a lot of different stuff, then your depth suffers as a result. And so obviously working on those skill sets would be beneficial. And for all of us, our tradecraft will improve. If as a defender, you know how an attacker thinks, the methodology of a framework like the cyber kill chain, then that's going to, I think, impact how you defend. Conversely, if you're an attacker and you know how a defender works their way through their operational mindset, then that's going to help you become a better attacker. So the obvious response to this is to use training. I think the talk before me was addressing challenges faced in the training industry. I unfortunately wasn't able to attend that, but I'm sure some of these points were raised in training. I found these interesting quotes from a source, Wombat Security, and I thought these were really good. So why does most cybersecurity training fail today? Number one, it's boring. So the key here is, how do we make this content more engaging, more interesting? Number two, lacks user interaction. This is a very key point. How many times have you seen or participated in a training course where it's paper-based or PowerPoint-based, and you're sitting in a chair, staring at a screen, and you check out? Number three, there's no measurement. Number four, scare versus teach. I think we're all guilty of that. And then number five, which is a really interesting one to me, education is not a security team's core competency. None of us, very few of us, want to do training per se, and it takes a certain mindset and approach to be an effective trainer. So these are all problems with traditional cybersecurity training. Another one that I would add is typically cybersecurity training is oriented mostly at cybersecurity people. Or if you're training on something like spear phishing, maybe you target non-cyber people, but there's really no in-between. At least there's not a lot of it. I think that's a problem. Also, I want to talk about product demonstration. This is something that I do a lot of in my role with my company. How many people here, another show of hands, have had to give product demonstrations? Okay. And do you ever get this response? Hopefully not. But I know that if you're giving a demonstration of your company's product, and let's say it's PowerPoint based, your audience is probably going to check out. And maybe they're interested in your product, but how do you make that more lively? How do you make it more interesting to your audience? And I think the point here is, if you can figure out how to position your product to your audience and really engage with them, your job is going to be a lot more effective. So problems in demonstration are very similar to problems in training in that typically they're briefing based, not interactive, and do not really engage the audience. And if those things happen, you're not going to be able to compel your audience to retain the key messages that are important to you and the organization that you represent. So, solution. So in my opinion and my experience, wargaming is a really effective solution to many of these problems. First, if you build a wargame environment, you have a tool at your disposal in which you can engage a great diversity of stakeholders, both technical and non-technical, both inside your company, outside your company. Second, if you design an environment with realism, an environment that allows your players to get on keyboard and immerse themselves into role-playing and work with teammates, it creates a much more immersive and entertaining environment. Entertaining is a very important point here, because if you entertain your audience, you have captured their attention. Next, use gaming techniques to enable team-based play. So I think you all get the point that in cybersecurity, we have to work as teams. Whether you're planning an offensive operation or whether you're reacting to an attack, you work with your teammates. So therefore, training should be the same way. Demonstration should be the same way. Next, we need to encourage participation by both novices and team them with people who have better skill sets. And with that team-based play, when you see novices or people with very few cybersecurity skill sets working with experts side by side, that's when you really start to see some exciting competition and learning happening. And then finally, use the game as a platform to both train and demonstrate. I think it's natural, if you look at this talk, you see that perhaps wargaming is, most of the value is in training, but this wargame environment, if you use it, if you build your own, you can use it for a lot of different things, and that's very exciting to me. The picture that I've put here is a picture of a lab that we have at my company. We call it the Matrix Room. And it was specifically designed to immerse the audience into whatever capability we're putting in front of them. So it may be hard for you to see the picture from back there, but the key point of this room's capabilities is you have a large display up on the wall that can be split up into many different displays, so we can kind of emulate an operations center type of environment. But more importantly, we can put participants in the game or in the demonstration on keyboard, and we can put them into the environment. And we have observed firsthand with just simple product demonstrations that the people that we put on those workstations are more engaged. You would think that maybe those displays are blocking their view or distract them, but it's the exact opposite. They're the ones that ask the most questions, and that confirms for us as presenters that they are the most checked into what we're trying to tell to them. Oops. Okay, here we go. On to definitions of serious gaming and wargaming. So, another show of hands. How many people here have heard the term serious gaming? It's kind of a new term. Basically, what serious gaming means is using gaming techniques and principles to do professional type stuff. And there are some really interesting use cases for using serious gaming. And I put the definition up there. I'm not going to read it to you. But serious gaming is a real thing. In addition, wargaming is a very important technique by which many militaries around the world, of course, use it to immerse their participants into more realistic environments. And the pictures I put up were a recent exercise conducted by the US military and one of its European partners. And you can see from the top picture the smoke and simulated fire that's happening. And I think you've all heard the term the fog of war. I think the important point is in military preparation, the more that you can do to immerse your soldiers and other associated personnel into that type of environment, they will be much more ready when the real thing occurs. And so wargaming has been in use for a very long time with great effect. So let's use those principles to do cybersecurity wargaming. So we built a wargame at SEIC, and it's been phenomenally successful. It has exceeded any expectations that I ever had. We've been developing this capability now for just over a year, and we've been supporting it in our spare time. We have no dedicated resources supporting it. It's really been a labor of love, and it started with the very first execution as a simple demonstration to our board of directors. And so what I show here is the agenda, the schedule of the game, and I'll walk through it with you. What we do is we gather the team, and teams typically range from 15 to 20 participating players, and we give it some time to get everybody in place, and we address the entire audience, and we give them a very quick introduction to what is cybersecurity, what is cyber warfare from an attacking mindset and from a defending mindset. We talk about the game, and we talk about game objectives and who the attackers are and what are their motivations and what are they targeting. And then we talk about what are the objectives of each of the teams, and then we tell each of the participants what team they're on. Up until that point, they don't know whether they're going to be on one of the red teams or on the blue team. And so then we tell them what teams they belong on, and we send them to their area. And the area can either be a separate room in our lab, or if we're on the road and in a conference environment like this, we'll have a large conference room divided into sub-areas. And so they'll go to their sub-area, and then we will ask each of the player coaches who is responsible for each of those teams to give a more detailed team brief. And so they will get more into roles, motivations, Why is this team doing what they're doing? For example, why is the hacktivist angry at their target? What is motivating them? And why are they attacking the assets? And what is their end state goal? So we'll spend a very short time on that. And then we'll reserve about 60 minutes, 1 hour, on the actual gameplay. So it's very, very fast paced. And I'll give you a better sense of what happens during that gameplay in a moment. Once the gameplay finishes, we'll gather everybody. We'll ask volunteers from each of the teams to develop a team briefing that is then given to the entire set of players. And those briefs are very interesting because they're given by the players, and they talk about what they learned, what went well, what didn't go well, comments for us as game administrators and what we can do better. And it's really amazing actually to hear the players talk about some very nuanced concepts about how the cyber kill chain was affected, what objectives were achieved, and how they could have done their attacks better. And that all happens during the team out brief. And then we'll announce a winner. That's actually quite important, is the teams know that they're being scored, and that adds a little bit of excitement and competitiveness to the environment, which is important to, again, give each of the participants more of a motivation to learn and participate. And then finally, we'll talk as a group about those debriefs and brainstorm about what they learned and how to make the game better and how the principles of the game applied to their job responsibilities. So 2.5 hours, start to finish. It goes very, very quick, and a lot of enthusiasm by the participants. So who are the teams? Generically speaking, we create 3 teams, 2 attackers and 1 defender. So 2 red teams, 1 blue team. And typically, if we have an overall game size of 15 players, we'll split it across 4, 4, 7. So 4 each to the red teams and about 7 for the blue team. And that makes sense because the blue team has their hands full because they're being attacked from multiple directions. So team 1 is the nation state. So this was important for us to have a group that role plays as a nation state. Nation states operate a little bit differently than other threat actors. They are typically more methodical, more organized, more resourced, have access to more resources such as insider threat, that sort of thing. Whereas team 2, hacktivists, they operate a little bit differently. They have different motivations. They have different targets, and their operations may go a little bit differently. And then team 3 is the blue team. Generically, they are responsible for operating a combination of information technology infrastructure, such as web servers, database servers, email servers, et cetera. But also, we have implemented emulated industrial control infrastructure to mimic an organization or a government that has responsibility for critical infrastructure, which is increasingly important in our world. So as I mentioned, all teams compete, they're all scored, and there is a winner. And the winning team oftentimes takes great pride in how they won. And typically, the teams that we observe winning are the ones that communicate the most. Invariably, that's the mark of success. Okay. So the way that we've designed the teams, the content, the frameworks in which these teams operate, we try to base it on real-world events. So for example, when we thought about how would we work with a nation-state team to attack a variety of IT and industrial control infrastructure, we used Stuxnet as a influencing event, and the lessons learned from that event are very important. And so we use that both in terms of how we've designed the game environment as well as how the operations are affected by the nation-state team. Similarly, the hacktivist team, we loosely model against a real-world event that happened with an organization by the name of HB Gary Federal, where some social engineering was very successfully implemented by the anonymous organization. They spoofed the help desk and they got access to an email system and then exfiltrated that data and embarrassed the company. So again, very different motivations between these events in terms of what those those teams were after, and they were both fantastically successful. And of course, numerous events that happen in our industry every day, every week, with vulnerable website plugins, machines exposed, unfortunately, to the internet that should not be, permissive firewalls inside of company infrastructure, this notion of insider threat, and too many open ports and services. So all of those things we've implemented in our game environment. So one of the big keys for this type of gaming framework to be successful, for us to be able to host players that have no cybersecurity skills, is this notion of player coach. So every one of our 3 teams has at least one dedicated player coach, and the responsibility for that player coach is to be the expert and to walk their teams through the operational framework and to advise how to go about performing reconnaissance or exploitation or the actual resulting attack. And the player coach has a lot of responsibility in this game environment because they have to work with their teams, coach them, mentor them, and based on how these teams work with each other and with the player coach, they will achieve their objectives, either fast or slow. The picture that you see here on the right is a portion of the script that we develop and we supply to the player coach, and it's basically a timed script that contains instructions, syntax, and basically is a guide for the player coach to help their teams achieve their objectives. So this is a very scripted game environment. And then inevitably, as we go through that 60 minutes of gameplay, as the player coach works with their teams, participants on those teams will then get on keyboard and actually take over and start executing many of the events, and that's exactly what we want to see. So, methodologies and frameworks. These are very important guiding instruments for our gameplay. On the left, you see a diagram that illustrates the cyber kill chain, which is a methodology for operations developed by an individual from within Lockheed Martin Corporation. And the cyber kill chain is very important for the operations on the red teams because they train cyber folks in terms of how do you methodically work your way through the entire process from starting with recon and ending in execution and maintenance. So this is very instrumental, particularly for non-cyber operators. We've had great success, involving contracting and recruiting people to walk through this cyber kill chain, and then they get, how does an operation actually work and how is it conducted. Conversely, on the blue team, for defensive operations, we use our own internal methodology, which is referred to as cybersecurity edge. It's a very generic methodology that defines, how does one react to attacks. And if I can pause the conversation, imagine you're trying to give a presentation to a customer on what a defensive framework represents. You're quickly going to lose your audience. But now, imagine if you embed your customer inside of a game environment where they are being attacked, and now they need to respond to those attacks. Now they get the methodology and the framework much more effectively. So it's been very useful for us as a organization to communicate what these frameworks really mean. So key to the gameplay, obviously we have 60 minutes of gameplay, but both before and after the gameplay is really where the learning and the knowledge happens. So invariably, we've given this game now, I think, 6 times, and it's almost always the same. The players will walk in, they will know, most participants in our games know very little about cybersecurity, but at about the 2-hour mark, they now get cyber operations. They understand the cyber kill chain. They understand the importance of critical infrastructure. They understand how social engineering and spear phishing really works and how devastating it can be. They get it, and it's really great to see. So, let me explain now a little bit about the technical architecture of the game environment. so that if you have interest in building your own environment, it's really not that difficult. And I'll share both products and toolkits that we use, and in a subsequent slide I'll show you a network logical diagram that shows the design of the networks that support the gameplay. So let me go through this. So first of all, we make heavy use of virtualization because we want to be efficient with this infrastructure, and so we use VMware vSphere for our hypervisor, and it's really fantastic to be able to manage all of the game networks and the game assets as virtual networks and virtual machines. It allows us to organize the game assets very efficiently. We use pfSense for routing and for firewalls, and so they're used for both actually administering the game environment as well. You'll see in a moment, we actually use the pfSense routers as part of the blue team's operations in terms of defeating attacks. We use, of course, within vSphere, we use virtual switches and virtual NICs, but also we use physical switches. Currently, we use a bunch of Netgear switches that allow us to connect laptops when we go out on the road and connect into the game environment, and then we launch vSphere consoles that actually allow our players to access the game content. We implement a red team network, which I'll show you in a minute, that kind of mimics a untrusted network such as the internet. We have multiple blue team networks that mimic how an industrial corporation or a government manages a combination of IT assets, industrial control assets, and there is some amount of segregation that you would expect. But of course, in our game environment, we expose too many assets on the internet, and there's a lot of permissive activity on the networks. One interesting thing about our game environment, and you'll see a link there at the bottom to the GitHub repository, we found a emulation of a oil refinery on GitHub, and it was really interesting to us because it's an actual implementation of a human-machine interface, an HMI, that communicates with an emulated refinery using Modbus over TCP. And that was perfect for us because it allowed us to implement within a virtual machine based on Linux a HMI and a refinery, which is exactly the type of thing that happens in industrial control environments. And so those are a really critical part of our game environment because they do communicate with industrial control protocols and therefore can be attacked. And I'll show you some pictures of that in a moment. And of course, as you would expect, we have vulnerable web and FTP servers. We design the networks so that once the IT networks and assets have been compromised and exploited, the attacker has the option to then pivot over to the industrial control systems, which of course that's what happened with Stuxnet, for example. We have a persistent environment located in our Reston, Virginia lab, and that's where we do kind of on-premises training and demonstration. But when we come to a conference like this, for example, and we conduct the war game, we'll actually port all of those virtual networks and machines onto a roadshow set of equipment, which is pictured actually on the lower right. We use very low-powered commodity equipment. Those are actually two fairly low-powered Dell desktop units with a bunch of memory. And that's kind of the basis for our virtualized game environment. And so we'll take that roadshow environment and ship about 10 boxes of servers, monitors, and laptops, and we'll send them to the conference that we're going to and assemble them. You'll see a picture of that in a moment. So let's see, did I cover all the products? We make extensive use of Offensive Security's Kali Linux for our attack platforms. And we use an interesting tool from a company called Next Defense, and I'll show you a picture of the Sophia product, but that's really useful for us because it's a graphical visualization of real-time network traffic, and it's a cool tool because it allows blue team operators to visualize the different protocols that are occurring across the networks, and it's very useful to see visually the attack and the exploitation happening in real time. We use a lot of Ubuntu Linux for web, DNS, and mail. We use WordPress and MySQL, as you would expect, to represent websites that can and do get taken down and defaced. And of course, there's a link to the open source project. I'll point out that last summer, we forked the code in that open source project. And by the way, the gentleman who owns that project Jan Seidel, I'm not sure if I'm pronouncing that correctly. We forked that code and made some enhancements, and it's available to all of you if you want to check it out and implement it yourselves. So here's a fairly ugly diagram showing the network segmentation, and I'll start at the upper left and go clockwise. It basically depicts kind of our roadshow equipment where we have two commodity servers that run the virtualization platform, and we connect them together with a physical switch, and then those are accessed by laptops. Optionally, we have the ability to uplink so that we can get internet access, but it's an important point that whenever we take this game environment on the road, it's completely isolated. We don't need internet access. We don't want internet access. That way the attack and the defense can happen in a much more controlled environment. The blue team assets are subdivided into three primary networks. IT network, as you would expect, has a combination of web, database servers. There's a Windows workstation that we have in there that emulates how an user on an IT network can be attacked with spear phishing and that sort of thing. And some of those assets are directly exposed on the internet, at least in our version of the internet. And there is certain connectivity between the IT network and the OT network. That stands for operational technology, and this is where assets would be deployed in an industrial control environment that communicate with actual industrial control or critical infrastructure. So those HMI boxes are there. Those are the Ubuntu-based HMIs that then communicate with the emulated oil refinery. I'll show you pictures of that in a moment. We, as I mentioned, we use pfSense for routing and firewall, and then there is connectivity between the red team network and the blue team networks. And that's part of the problem, and that's part of the challenge to the blue team, is to figure that out and then react to the attacks. And then you'll see from the red team network that we have a variety of attack platforms based on, of course, Kali Linux, which is a wonderful capability. Here's some screenshots. My apologies for this collage being perhaps hard to see. I'll start on the upper left. That's a view of pfSense, and that's really critical for our blue team to learn as an attack happens. The team has to work with one another to figure out where is that attack coming from, what is that IP address, what are they targeting, what protocol is it coming across, and then one of the techniques that they can leverage as a defensive countermeasure is, of course, to create a firewall rule, but that's just temporary. You know, they need to think about what is the vulnerability that was exploited, and let's try to shut that down. But certainly, they have at their disposal the ability to create firewall rules, which can be either very expansive in terms of shutting down entire networks, or very specific. Next over is a view of the HMI. It's titled the Crude Oil Pretreatment Unit, and it's a pretty ugly interface. But what is interesting about this HMI is those push buttons and the color-coded statuses represent kind of a fairly realistic HMI, and anytime an operator pushes those buttons, it generates a Modbus transaction over TCP, and it's sent to the emulated oil refinery, which is pictured on the upper right. And that is a well-functioning oil refinery. You can see the red dots are actually emulated oil flowing through the refinery. And the key here is those commands that are executed from the HMI to the refinery can be spoofed. You can do replay attacks. You can do denial of service attacks. And that's one of the primary objectives of our nation state team. Lower left is a emulated website operated by the Ukraine oil company, a fictitious organization. Bottom center is just a view of one of our attack workstations. And if you can see in the background, that's a terminal where we're doing WordPress-specific exploitation. And then here's the graphical version of Nmap, where the attacker is seeing the open ports and services for one of the target assets. And then lower right is a view of that Sophia product that I described to you. The picture doesn't really do it justice, but it's very important in our game environment that you have a graphical visualization of network traffic. It really helps, especially cyber novices, understand how an attack actually looks in terms of protocols, source, and destination. So some pictures of actual war games that we've conducted, and the next set of pictures I'd like to thank press that actually covered our event back in February of this year. This was the first time we took the war game on the road, and we took it to an industry event run by AVCIA, and it was called the AVCIA Cyber Symposium in Colorado Springs. And so this was our first kind of experimentation with conducting the war game on the road, and when we used the portable environment. And the press was there to cover it, and got a lot of really good exposure, and it was really cool. This is a picture of a gentleman participating on the blue team, and you can see from the background that the blue team is not doing so well. Their website has been defaced, and at this point the hacktivist group has pivoted from defacement and is probably stealing corporate data. So the blue team is very busy at this point trying to figure out what's going on and how to defeat the attack. Also from the same event, this is a picture of the hacktivist cell. On the right is one of our players, and I remember this player. She was pretty funny. She walked in with decent, I wouldn't say great cyber skills, but decent familiarity with cybersecurity attack and defense. By the end of the event, she's literally running 2 different laptops at the same time, running reconnaissance and exploitation at the same time. And one of our player coaches, Zach Klein, there in the center, is just simply watching and admiring how they're going about their operations. It was pretty cool to see them do their thing. Those of you that have been involved in the IT industry understand the play on words here. But one thing that we make heavy use of, both for our player coaches as well as for our participants, is we use reference manuals and reference sheets that give a lot of detail should we need them, and how to use Metasploit, what is the syntax for nmap, all that sort of stuff. We have reference guides for that. They're very useful for both the coaches and the players. Another picture from that event, this is the other red team. I believe this is the nation state team. And the guy in the background is actually local press. And you can see from the facial expressions of these participants, they are involved, they are checked in. And it was great to see this type of interest and involvement, because they're really operating like a red team nation state. Okay, this is a picture from the last event that we went to on the road, and it's a picture of a fairly generic conference room that we deployed our equipment to. This is a picture of, basically when we first get set up. It takes us about 2 hours or so, start to finish, to unbox all of our equipment, separate all the gear, run the network, and you can see those round tables back there are basically where we're putting 2 attack teams. And this happened, the time that we took this picture was before the conference people came in and ran curtains that separated all the teams. And that's a kind of a useful technique for us to separate the teams from each other. And in the foreground here is our server infrastructure, which again is those commodity Dell workstations that serve up the game content. And again, the network that we run is all isolated. It's all wired 100 megabit and gigabit Ethernet, and gives us control over all of the attack and defense that's happening on the private network. This is a picture also from that event where, so show of hands, how many people here have had to help your company present at your company's booth? Yes, I share your pain. It's fairly monotonous duty, standing there waiting for somebody to show up at your booth and show interest. But I'll tell you, if you can actually bring a game environment to that booth, it gives you a powerful capability to connect with your audience, whoever they might be. And so what we did recently, this was back in June of this year, just a month and a half ago or so, was we experimented with actually advertising mini games themselves at the booth, and we invited people to come and sign up and participate. We had I guess, not as much enthusiasm about actually coming and signing up and participating in a game. But what we did have a lot of success with was when we did have people come up to the booth, we turned around the keyboards and let our participants actually play the game. And it was a great way of demonstrating corporate capability in the areas that we wanted to demonstrate. So how has this game evolution? I mentioned to you that we've only been building this now for a year. 5 minutes, thank you. So it's been iterative. Again, we support this in our spare time. The first one was last year, given to the board of directors. Then we invited our strategic alliance vendor partners to participate, so we beefed up the technical content. The big evolution was when we ported it to roadshow equipment and did the event in AFCEA in February. Then we tailored the game to add things like IP spoofing and geospatial visualization for a geospatial intelligence conference back in June. Then recently we enhanced our social media content, such as fake Facebook pages that can be used for spear phishing. And then in a couple of weeks we'll be taking it to another AFCEA event, and we're going to be, we've got 40 people signed up to take the training for the next version of the war game. Real quickly, results. We've been highly successful in increasing awareness of cybersecurity to non-technical stakeholders, and I'll show you some quotes here in a moment. We've been successful in getting people with legit cyber skills on keyboard and refreshing their memory and their skill sets in toolkits like Kali and how to use industry best practice frameworks. We've been highly successful in increasing our company's brand by showing the war game and by hosting the war game. We've actually been successful in generating opportunities from a business development perspective. We've had customers actually tell us that wargaming is a strategic priority for their organization and been given some very good clues. And then finally, the war game is a very useful tool for me to work with our company alliance partners. I'll show you some quotes that are really interesting. These are mostly from non-technical folks, and they're kind of instructive. A recruiter said a lot of fun, and she literally used 4 exclamation points, so she had a lot of fun. That was good. A pricing analyst, of all people, says cybersecurity is paramount to day-to-day operations. That was kind of good that they now realize that. I don't know if they realized that before. A cool thing about recruitment, by our recruiter participating, they now are in a much better position to actually understand how to recruit for cyber people and what do those key terms mean. As I mentioned, one of our customer executives stopped by and said that wargaming is actually one of their top 4 strategic research priorities. So that was really interesting. And one of the senior members of our country's intelligence community stopped by and simply said, "This is really cool." So we were glad that she liked that. And then finally, where is this headed? We need to make the equipment more efficient. It doesn't scale very well right now, and we want to be able to expand past group sizes of 15 to 20. We're going to add more infrastructure to support man-in-the-middle attacks. So we're going to add email servers, DNS servers, et cetera. We're going to take a look at Internet of Things assets for both attack and defense. And we're going to be looking at implementing more of our strategic alliance partners content. And then finally, we're working with some of our corporate R&D projects to embed some cool capabilities. Thank you so much for staying. Thank you, Black Hat. It's been a real privilege. Any time for questions? 2 minutes. If anybody has questions, I'd welcome you either at the microphone or come on up to the desk. What's that? Okay, Reef A is going to be where I adjourn. If you have any questions, I'd be happy to address.
Got a quick question for you. For setup of the environment, do you guys, I'm assuming you use snapshotting, but do you also use automation like Ansible or anything to finish the setup when you reset the environment?
Very little automation. It's actually a problem. We can very much take advantage of automation to help kind of the setup and recovery. Currently, we simply go back to the snapshots that we've developed, restore the environments, because in some cases, some of our environments have been totally trashed. There was one case where a defending team recognized within the first couple of minutes that the WordPress plugins were quite old, and that there was no need for file upload capability on the public-facing website, so they crushed it. They deleted it, and we're like, holy crap, we need to restore this website.
Thank you.
You're welcome.
Question.
Yes, sir.
Have you considered running all the server side things in the cloud? If you have you encountered any big challenges to make you decide to run all those servers in physical systems?
So you're asking, I'm sorry, about whether we're running on the cloud versus physical systems?
I mean, is it going to be easy to run all the servers in the cloud, making the deployment easier?
We could. The problem that we've run into, especially at conferences like this, is how do you get to the cloud assets? We've actually run into a lot of problems at certain conferences in the quality of the network, especially with Wi-Fi. So when we went to the first conference where we brought the portable infrastructure, we wanted to eliminate that problem, so we implemented our own private network. It is completely doable to run all these assets in the cloud. We just haven't done that yet. Thank you for the question.
Thank you.
Okay, we're going to adjourn now. Thank you again, everybody.